You are welcome to the Scholar online class. I will be your mathematics teacher for today, and my name is Mr. Abdulwasi. And our topic for today is on trigonometric ratio or trigonometry. So under this, we'll be looking at trigonometric ratio, we'll be looking at inverse of trig ratios, proof of sine squared theta plus cos squared theta is equals to 1. We'll also look at complementary angles, special angles such as 0 degrees, 30 degrees, 60 degrees, 45 and 90 degrees, then the application of the trig ratios. Now let's move to the inverse. The inverse of what? The inverse of trig ratios. When you say the inverse of something, it means what? 1 over. For example, if I ask you what is the inverse of 2, it means 1 over 2. What is the inverse of 3? It means 1 over 3. What is the inverse of A? It means 1 over A. Now, that is very good. What about if I say what is the inverse of 1 over X? It means the opposite, which is what? X over 1. So anytime you talk inverse, it means the opposite of what you have initially. So we now want to look at the inverse of this trig ratio. So inverse of trig ratio. The trig there means what? Trigonometric ratio. So, and the first one, it's sine theta. The inverse of sine, the inverse of cosine, and the inverse of tangent. So we define the first one as secant. That's the first inverse, secant. Or these are the three inverse. Secant. The second one is what? Cosecant. And the third one is what? Cotangent. These are the three inverse that we have, which, just like I did for this one, we use the first three letters. So our secant, we abbreviate it as what? Sec. Our cosecant as cosec. And our cotangent as what? Cot. COT rather. So these three now is what I'm going to be using henceforth for our inverse. So now how do we define the inverse here? Let's take the first one. Sec theta. Sec theta is equals to what? 1 over cos theta. That is the definition. So it means that the inverse sec theta is what? The inverse of what? Cos theta. And vice versa. The second one, cosec theta, is defined as 1 over what? Sine theta. It means the inverse of cosec is what? 1 over sine theta. And the last one, cot theta, is equals to 1 over tan theta. Cotangent is what? The inverse of what? Tan theta. This can also be written as what? Cos theta over sine theta. Since we said tan theta is what? Sine theta over cos theta. So the inverse will what? You take it up. The numerator will become the denominator and vice versa. I hope that is clear. So these are the three inverse. Now, how do you identify the inverse? It is very simple. When you talk about sec, you see that the initial letter is what? S. On the other side, what you are going to have is C. So if you have S on this left-hand side, the other side will be C. If you have C on this left-hand side, the other side will be what? S. And that is the easiest way to what? To identify the inverse of all these things. So it is very straightforward. So that is what? The inverse of our trig ratio. Now, the next one we are moving to is what? The proof of sine squared theta plus cos squared theta is equals to 1. But before we can do that, we need to refresh our memory on what we call Pythagoras theorem. And when we talk about Pythagoras theorem, it's a theorem that is very, very important in mathematics. Now, let's say we are given a right angle triangle. I will state what the law states briefly. Triangle ABC with side, this is small letter C, this is small letter B, and this is small letter A, so that to conform with what I want to do here. Now, according to Pythagoras theorem, it states that in a right angle triangle, the square of the hypotenuse is equals to the sum of the square of the two adjacent sides. That is one way to state it. The other way to state it is that what? In a right angle triangle, the square of the hypotenuse is equals to the sum of the squares of the other two sides. I repeat, in a right angle triangle, the square of the hypotenuse, which is the longest side, that is AC, is equal to what? The sum of the squares of the other two sides. So briefly, mathematically, it means that the hypotenuse is still what? Our AC. It means that AC squared is equal to what? We put it this way in convention. So this double parenthesis means what? Line AC is equal to what? AB squared plus BC squared. This is what we call Pythagoras theorem. The square of the hypotenuse is equal to the sum of the squares of the what? The other two sides. It means that if two sides are known, I can easily get the third side. Let's look at the application. For example, let's say I'm giving a right angle triangle in this form. PQR. Let's say this is 4 and this is 5, and I'm asked to find x. It is very straightforward. Here now, two sides are known. To get the third side, you use what we call Pythagoras theorem. This is applicable to what? Only right angle triangle, not any other triangle, only right angle triangle. So in this context now, if I'm to get x, I'll apply the law. The hypotenuse is what? PQ. So I have PQ, line PQ squared is equals to line PR squared is equals to line PQ squared plus line QR squared. This is another way to write line if I don't want to use double lines. So substituting that means I have what? X squared is equals to what? 4 squared plus 5 raised to power 2. That means x squared is equals to 4 squared is 4 times 4, 16. 5 times 5, 25. That means I have x squared is equals to 16 plus 25. That will give us 41. Then what do you do now? You take the square root of both sides to get the square root. So when you take the square root of both sides, that means I have square root of x squared is equal to the square root of 41. When you say square root, means two numbers that are the same, you pick one. So the x squared is what? X times x. So the square root of x squared gives us what? 1x equals the square root of 41. And by your calculation, you get your answer in decimal because this is what? A prime number. How that is taken. So this is how you apply Pythagoras theorem in case you are looking for any side. So this is going to help us when it comes to the proof. That's why we need to understand this concept of our Pythagoras theorem. So let's move on from there. So we are to prove that sine squared theta plus cos squared theta is equals to 1 in a right angle triangle. Now we have our sine theta, cos theta, and tan theta. So everything is stated here. Now using the same Pythagoras theorem that I've stated here now, from Pythagoras theorem, we state that what? Line AC squared is equals to line AB squared plus line BC squared. Now my AC is B squared. My AB is what? C squared, and my BC is what? A squared. I hope you are following. Mind you, I have my sin theta is what? C over B, and my cos theta is what? A over B. We are to prove that sin squared theta plus cos squared theta is equals to 1. From this expression that I have here, if I divide all through by B, divide all through by B raised to power 2. That means I have B raised to power 2 over B raised to power 2 is equals to C raised to power 2 over B raised to power 2 plus A raised to power 2 over B raised to power 2. So this cancel this, that's what? 1 is equals to C raised to power 2 over B raised to power 2 plus A raised to power 2 all over B raised to power 2. I hope you are with me. Now, going back to this first expression that I have here, my sin theta is defined as what? That is what? C over B. And my cos theta is defined as what? A over B. I hope you are with me. If I now substitute this into this expression that I have here, then I'm going to get something very important and something very tangible. If I substitute this, that is from my 1 is equals to C squared over B squared plus what? A squared over B squared. Remember that these two expressions, they have something in common. What do they have in common? The square. So that means I have 1 is equals to C over B, everything squared, plus A over B, everything squared. And I have sine theta is equal to what? C over B. Meaning, if I bring this into this expression, I'm going to have 1 is equal to what? Sine theta, everything squared. Since sine theta is what? C over B. Are you with me? Likewise, my cos theta is what? A over B. If I bring it into this, I'm going to have cos theta raised to power what? 2. So therefore, sine squared theta plus cos squared theta is equal to 1. And that is the proof. You have to prove that sine squared theta plus cos squared theta is equal to 1. I hope you are with me. And that is a very good expression, or a very good proof when it comes to what? Trigonometry ratio.